Hey guys, welcome to 12.3. We're going to be solving quadratics by factoring. So in 12.2, we solved quadratics that were already in factored form. So that's like these first two examples up here. It looks like this. It's in factored form. And what we would do with this is we would set this equal to 0 and this equal to 0. Because in order for both of these things, either A has to be 0 or B has to be 0 in order for these to multiply to equal 0. Or they could both be 0, but at least one of them had to equal 0. So we set them both equal, and we solved to get x by itself and figure out what it was that x had to equal for this to equal 0. So this would have to be 7, like if I plugged in 7 here. 7 minus 7 is 0. And it doesn't matter what, this could be any number in the whole wide world. 0 times any number is going to be 0, which is what we want. So 7 works, but we could also have the other side equal. So we're going to subtract 3 from both sides, and I could have x equals -3. So these would be the solutions to the quadratic equation. Okay, that's the solution. Again, you could graph it. Our solution is also, remember the word socks. And remember, SOX stands for solutions, zeros, and x-intercepts. And then another word was roots also. That one didn't really fit in with SOX, but all four of those things mean the exact same thing. So if I'm looking for the solution, all I'm really looking for is where does it cross the x-axis? So you can plug these equations into Desmos and you can see where does it cross the x-axis. So this one would cross, if I were to graph it, it would cross and it would have a cross at 7 and a cross at -3 is where it would cross the x-axis. And that's our solutions. So right there is what we're looking at. Okay. Another one like what we did not yesterday, it was like a week ago. Again, set it equal to 0. Set this side equal to 0. I'm going to add 5. This is actually a two-step equation. So 2x equals 5. Divide by 2. So x equals 5 over 2, or x equals -6. So, whoops. Again, there's my two solutions. Remember, quadratic equations can either have two solutions, one solution, or 0 solutions. So in this case, they both had two solutions. That means they're crossing the x-axis twice, like we saw right there. Okay, so what if it's not in factored form? What if they don't give it to us pretty like this? Because they're not going to give it to you pretty like this, sadly. It says, what do you do if they are not factored? So 1, this is so important. Like, make sure you remember this. This is very, very important. Okay. You have to make sure that the equation equals 0. So if it doesn't equal 0, we have to make sure it equals 0. So if there's something, if we look at number 1, like we have all of this stuff over here and 0 on this side, that's what we want. If you had something besides 0, you would have to move it over to that everything else side. Once you have it equal to 0, you're going to factor the trinomial, like do our x puzzles. So that's really what this means. Do your x puzzles, and then you solve each factors. And that's what we did up here. So once you have it here, you set them equal to 0 and solve the factors. So let's try. Okay, so quick little factoring check to make sure we know. Remember, this is our a term. It's next to x squared. B term is next to x. C term is by itself. So in this case, we have a equals 1 because there's 1 x squared, right? B equals 7 and C equals 12, not 17. Okay, so if I do my x, a times c goes on top, so 1 times 12, which is 12. B goes on bottom. I am now thinking of two numbers that multiply to 12, but also add to 7. So the first ones that pop in my head is 3 and 4. 3 times 4 is 12. 3 plus 4 is 7. Okay, step number next is to divide by your a term, which our a term is just 1. So I'm dividing by 1 and then whatever the variable is, whatever your letter is. In this case, we have x, so 1x. If you can simplify, you simplify. Again, the ones we don't really need, because if I divide anything by 1, it's just going to be itself. So 3 divided by 1 is just 3. So I still have 3x, 4x. Then we do our magic trick, and this turns into bottom. It's a positive fraction, so it's plus 3. And then bottom, positive fraction, so it's plus 4. Okay, and I still have all of this. Remember, I just took this part, so all of this is still equal to 0, which is what we want. Now we're on to step 3, which now this looks exactly like these problems right here that we just did and we knew how to do. I set these equal to 0. So x plus 3 equals 0 and x plus 4 equals 0. If I subtract 3, I'm left with x equals negative 3. That's 1. And then minus 4. X equals negative 4. So there's our two solutions. Again, if we were to graph this, it would cross at negative 3 and negative 4 would be the solution there. Ta-da! So not bad. So the 3 things we know how to do. We're just combining it all into one. So again, let's do this one. So my A term, A is 1, B this time is negative 8, and C is 15. Okay, so if I do my X puzzle, A times C is 15. 1 times 15 is 15. I bring down the negative 8. Now I'm thinking of two numbers that multiply to 15, but also add to negative 8. So I'm thinking negative 3 and negative 5. Okay, negative times the negative gives me that positive 15, and then the negative plus the negative give me that negative 8. Then I divide by my A term, which is just 1. And again, this time it's x as my variable. Well, when this goes to simplify, I have negative 3 over x and negative 5 over x. I do my magic trick, and I'm left with x. This time it's minus because it's a negative fraction, and x minus, again, negative fraction, and it's all still equal to 0. It's equal to 0 here. Okay, from here, we do what we did on the top of it, right? X minus 3 equals 0, x minus 5 equals 0. It's in that pre-factored form now, and we know how to solve these. So if I add 3 to both sides, I'm left with x equals 3, and then add 5, x equals 5 are my two solutions. And then, again, just to show you, if you were to go to Desmos and we were to type in the equation they gave us, x squared minus 8x plus 15 equals 0. Don't put the equal 0 part. As you can see, that makes it go away and gives you the little error. Just leave that off. Just make sure everything's on the left side and plug it in. Then we can look here. Where it crosses my x-axis is 3 and 5, which again is what I just got here, 3 and 5. So really not bad. Let's look at number 3 though. So number 3 breaks our rule, like our golden rule up here. I highlighted it in yellow so we wouldn't miss it. Make sure the equation equals 0. It's not going to work if it doesn't equal 0. So if it doesn't, I just have to make sure I move everything. So like this 35 has to get moved over first. So if it's a positive 35, I'm going to subtract 35 from both sides. So when I do that, I'm left with x squared plus 2x minus 35. Now there's nothing over there, so now it equals 0 because there's nothing there. Then I can move on to doing my x puzzles. So on top of them I have negative 35. Again, I've got that imaginary one right there, 1. times negative 35 is just negative 35, and then bring down the 2, right? Okay, so this one, nothing's popping to me at the top of my head. So I might make a list of the factors that multiply to 35. I'm just going to do positive 35, and then I can play with the negative later. So things that multiply to 35. 1 times 35. 2 does not go in there. 3 does not go in there. 4 does not go in there. But I do know 5 goes in there. So 5 times 7. 6, no. And I'm back to 7. So those are my only options. So if I look here, 5 and 7, that's going to work, right? So I need it to, when they add together, to be positive. So I'm going to make the 7 positive, the 5 negative. So when I multiply them, it's the negative 35. Add them, it's the positive 2. Okay. So from here again, I divide by that a term, which is just 1. And again, it's x, right? I think I used a different color there. Yep. Sorry, I'm trying to stick with the same colors. Okay. So again, whoops. 1x, 1x. Then I can simplify. Again, if this was a different number besides 1, these are all have coefficients of 1, you would divide it out and simplify it if it could be simplified. In this case, we just don't need to because it's 1. Then I write my factors. So x plus 7, x minus 5. And again, it equals 0 because that's what we had up here, equals 0. From here, it's like the ones we had on the very top. X plus 7 equals 0. X minus 5 equals 0. Now I can subtract 7 from both sides. X equals negative 7. So there's one of my solutions. And x equals positive 5 for another one of my solutions. So again, this is going to cross twice at those 2 spots. So again, just mixing everything we know. This guy, again, it's not equaling 0, it's equaling this, so that's a no-go. I've got to move that over first. So I'm going to add 2x squared, to both sides. So now I have 2x squared, but I still have the 11x, and I still have the 15, and now it equals nothing. It equals 0. There's nothing left over there. So now when I get started to do my x puzzle, it's a times c, which this time a is 2, c is 15. So 2 times 15 is going to give me 30, and then 11 on the bottom. Good so far? Then I'm going to see what multiplies and adds, so I can go through the list. And the first thing that pops in my mind is the 5 and 6, right? Factors of 5. 5 times 6 is 30. 5 plus 6 is 11. Next, I'm dividing by the a. This time the a is 2, so everything gets divided by 2, and again, the variable's x. Notice this cannot be simplified. There's the word. Can't be simplified, so this stays at 5 over 2x. This one can be. I can divide the top by 2, and I can also divide the bottom by 2. So when we simplify this one, right, that we're simplifying. When I simplify it, I'm going to have 6 divided by 2 is 3, and then 2 divided by 2 is just x, or 1x. So now that it's simplified, I can make my magic trick work, turn my fractions into factors. So 2x plus 5 times x plus 3. And again, that all equals 0 because that's what I had it equal to up here. Now it's just like the problems we had up there. It was just all of a sudden equal to 0 and solve. So subtract 5, and I'm left with 2x equals negative 5. Divide everything by 2. X equals negative 5 over 2 is one of them. And then minus 3, so x equals negative 3 is another one. So again, that's where it would cross your x-axis. These are just like the other one. I'm not even going to do them. These are just like above. Just like above. Again, this time you have a 6 as your A term and a 3 as your A term, so there will be simplifying for these, like this one over here we had to simplify. Let's look here. So this one's a difference of squares. So notice we were to do write what our A, B, and C terms were. A would be 1, right? Obviously, there's 1 there. B, there is no B term. There's no term next to X. There's not just an X. So there's 0 X's. And then C term would be negative 25. So notice it already equals 0. If I were to do my X puzzle from here, 1 times negative 25 is negative 25. And then B is 0. Well, the only thing that multiplies to negative 25 and adds to 0 would be negative 5, positive 5. Again, 1x, because this A is 1. So I have negative 5 over x, and then I have positive 5 over x. When I do my magic trick, I've got x minus 5 and x plus 5. And again, that all equals 0. So in this case, when I set them equal, x minus 5 equals 0, x plus 5 equals 0. I'm left with x equals 5. And x equals negative 5. So those are my 2 solutions. Remember, with difference of squares, though, you really didn't have to do all of this work right here, okay? It's difference of squares. So that square is going to bug me. Sorry, y'all. That's not even a square either, but whatever. Okay. Remember, you can just take the square root of this number, which is 5, and you know it's going to be, when I take the square root, I can do positive or negative 5. So right off there, I know the answer. So if there's not a B term, you can just take the square root of your C, and you can get that positive 5 and negative 5. Right. Okay, so same, I mean, these are kind of the same thing. Again, number 9 is a word problem. Rectangle has a length of x minus 4 and a width of x plus 2. Area, which is length times width, is 91. So again, if we were to do 91 equals the length, I don't know, I did x plus w, but it's supposed to be x plus 2. The length, which we said was x minus 4, times my width, which was x plus 2. Then you solve. So remember, you have to have it equal to 0 first. So you would need to move that 91 over, need to do box method, all of that stuff with this problem. So this one does take a few more. I guess I'll just go ahead and do it. So this time I'm going to do box method first. So this, we're going to do box or FOIL, whatever method you do. So if you're doing box, I've got x minus 4, x plus 2. So if we do that, I've got x squared, negative 4x, 2x, and negative 8. Again, my diagonals are my like terms. So now I've got 91 equals x squared. 2x minus 4x is negative 2x minus 8. again, it has to be equal to 0. So this 91 has to get moved over. And I can combine it with that -8. So it's really 0 equals x squared minus 2x minus 99. Same signs we had, right? So now you can do your X puzzles and things. On your homework, Monday, March 22nd. It's 12.3, solving quadratics by factoring. The first couple are what we did at the very beginning of the notes and what we did like over a week ago before spring break, just to kind of do a review on those. These are all select all that applies. So you could select all of them. You could select one of them, two of them. Like most of the time it's going to be 2 because remember quadratics most of the time they cross the x-axis twice. But there's that. Starting with number 6 is what we did today. So you set up the X puzzles and solve those. And there's 12 problems, so not bad. Bye, y'all. Y'all have a great rest of your day.